Okay, good morning everyone. I'm Alberto Monge, the second teacher for this course. Some of you already knows me, but anyway, I work in the same group of Luigi De Russis. My main research topic is about digital well-being. So in our research we are interested in designing technology that supports users and we are also interested in avoiding problems like technology overuse, attention capture patterns like the infinite scrolling on your social networks and so on. So, and this is clearly a research topic that is strictly related to human-AI interaction. Anyway, today we will start focusing on designing interactive systems that have some sort of AI in the middle. So we will see some interaction paradigms through which users can interact with AI, because before designing we obviously need to understand how people can interact with these systems, and then we will explore some guidelines to start designing this system and also to evaluate this system. But before starting, today in the second 2 hours we will have the second exercise, and this will be a group exercise. So you will work in group, and this is the situation right now of the groups. There are some groups that are already, I would say, completed, and there is group number 4 and number 7 that are still of 2 people. So I don't know if group number 4 and 7 are here. Number 4, and what about number 7? 7. Okay, maybe the best option is to merge the 2 groups, if that's okay for you, so that we have all groups of 4 people. Okay, you can also check with your colleague, but I can start. Where is the cursor? Okay, anyway, I will. Yes. Okay, perfect. So in the second 2 hours you will work in group. It will be a sort of workshop. You will try to evaluate a fictional mobile application that includes some AI by using the guidelines that we will see in this lesson. Okay? Any questions? Okay, so let's start. Okay. So this is the summary for today. Again, we will explore some paradigms for human-AI interaction. We will see when this interaction may go wrong and how can we react to these errors. And then we will focus on specific guidelines for human-AI interaction that can be used both for designing systems but also for evaluating existing systems. And then we will have the exercise. So let's start with interaction paradigms. We will see some videos. I will ask you some questions, so it will be hopefully interactive. I think you have already seen this figure here that is about the human-centered artificial intelligence framework, which has been proposed by Ben Snederman. So you probably discussed also in the panel about having systems that have a high degree of automation versus a low degree of automation, and the same system can provide high control to the users or a low degree of control to the user. So that means a high degree of control for the computer. Okay, and in this chart we can have different kind of systems, and the idea is that systems that have a high degree of automation but still offer a high degree of control to the user are systems that are reliable, safe, and trustworthy. Okay, so in a way, in our goal is to have probably systems that are here in the framework. And again, we will see a set of examples of systems that have some AI in the middle, and we will try to put these examples here in the slides, in the framework. Okay. We will also try to analyze these examples in terms of possible errors or problems, in particular in terms of gulf of execution and gulf of evaluation. I don't know if you have addressed these two problems in the past lectures. Do you know what is the gulf of execution? What is?
The loop of action and then the execution and feedback by the system, and the gulf of execution is the distance between the user.
Okay. So, in a way, the gulf of execution is the gap between how the user thinks the system works and how the system actually works. Okay. So obviously our goal is to minimize this sort of gap, this sort of gulf. But there are cases in which the user think about a system in a certain way, but actually the system works in another way. Okay, so when there is this gap, this means that the gulf of execution is large. And then we can also have the gulf of evaluation. Okay, so the user performs something on the system, execution, and then receives some feedback, and the system, the status of the system changes. And the gulf of evaluation is the difficulty of assessing the state of the system, okay, which has probably changed. So when we perform some actions and we see something strange on the screen, something unexpected, this means that the gulf of evaluation is very large, okay? So the first example, I don't have a video for this, but it's quite clear. It's the Gmail spam filter, okay? So the Gmail spam filter can classify spam and warn you about potential undesired messages, okay? So first of all, where is the AI here? And is it more a system for automating something or for augmenting something? I hope you have seen this distinction in the panel. So is it more automating or augmenting, in your opinion? Automation. Yeah, probably automation. And where is the automation here? Yes, it automatically moves emails in the spam folder. So it's automatic. It classifies something, and without your input, it automatically moves something into the spam folder. And what about the interaction the user can have with this system? How can the user interact with this system, with the Gmail spam filter? Okay, the user can modify blacklist of contacts. Yes, in a way. Yeah, exactly. This is the main interaction that the user can have directly with this system. Then you can indirectly also interact, for example, by manually checking the spam folder. But with the system directly, you can revert a decision of the system by clicking on look safe. And if you click on look safe, the email, I think it's automatically moved into your inbox folder, right? So there is no input needed to start the system, which is automatic again, but the user can override the system decision clicking on look safe, okay? So it's a quite simple tool. Just one action And where would you put this system in this framework? In the bottom left square, so here. So we are saying that this is a system that has a low degree of automation and a low degree of control for the user. Do you agree?
Bottom right.
In the bottom right, here, here. So we have diverging ideas.
That should be considered the number of tasks that are automated,
Mm-hmm.
or the kind of task that is automated?
I don't think there is a clear answer to this question. Probably we could consider the single task. Okay, so we know that there are systems that are more complex than others, but let's focus on the single task of classifying an email. In this case, I would say that it's a quite automatic task because the email is moved in the spam folder automatically without the user interaction, without any user interaction. So I would agree that this system can be considered as a system that has a quite high degree of automation, and also I would say that human is quite in control, okay? Because the user can click on the look safe button. So the user can always revert the action of the system. So I would agree with your colleague. I would put this system probably here. So there is an automation, but there is also some control. It's not full control because the first decision is taken by the system automatically, but still you have control. And what about, okay, there is just one action here to be executed, so probably the gulf of execution is quite small, but what about the gulf of evaluation? What are the problems that can arise with this system in terms of evaluating the state of the system? Can you identify a case in which the gulf of evaluation with this system is probably high?
Well, you don't see the effects right away on the modifying a mail from the mailing list. I mean, if you click it, this looks safe. Single mail is moved, but you have to wait for other mails to see if that affects in any way.
Okay, this can be an example. If you click look safe, you are acting on this specific email, but you cannot know if other emails from the same address will be classified again as spam or not. And the other example can be there is an email that has been classified as a spam, but it's actually an email from a wanted contact, from a real contact. So you don't know exactly why the system has classified that mail as a spam. Okay, so you are not able to fully evaluate the state of the system because you don't have an explanation of why that email has been classified as a spam. Okay. Okay, let's see another example. Now we have a video, so it's more interesting. Let's see if it works. No, let's try.
Is Nest thermostat. This is Nest thermostat from Google. It's a smart thermostat that can help you save energy, which helps you save money on your energy bill. And with all those heating and cooling savings, replacing your old thermostat is almost a no-brainer. You're probably thinking, oh wow, but how? Well, this thermostat can help you build an energy-saving schedule and then adjust automatically, so you don't waste energy when you're away. You just have to select preferences, such as what temperature you like for when you're home, or when you're asleep, or when you're gone, and then plug in your schedule. You know what else is cool? The Nest thermostat is kind of like an energy-saving advisor. It can help you find opportunities to use less energy. Like it might send a suggestion to tweak your sleep temperature settings, so you can save while you snooze. It can also help keep tabs on your heating and cooling system and sends you helpful reminders, like when you need a filter changed. It can even alert you if something doesn't seem right and help you find a qualified pro for a system checkup or repair, so you can get things working right and go back to living life. And say you're at the park and want to come home to a perfectly cool house. You can go to the Google Home app and take care of that. You can also control the thermostat from your Nest speaker. Hey Google, raise the temperature. Maybe you're thinking, is this fancy thermostat real expensive? Well, actually, it isn't. With rebates from your utility company, you can get it for even less. Oh, and if you like to DIY around your HOM need, the Nest thermostat is designed so you can install it yourself, so you don't have to hire anyone to do it for you. But if you want, you can have a pro come install it instead. And that's how you can save energy and money with Nest thermostat from Google.
Registration will not work. Yes. Okay. It works. Okay. So what is this? Are you familiar with the Google Nest? Do you have a Google Nest at home or not? No. Okay, so obviously it's quite clear. It's the smart thermostat by Google. What is the main goal of this object, of this system? And where is the AI here? Let's start from the goal, which is the main goal of this thermostat. Why you should buy this thermostat? You don't have to manually set up the temperature, that's right, but why? Which is the main goal? It has been mentioned in the video. Yeah, it's probably saving energy, because the Nest can recognize, for example, your habits when you are outside home, so it can automatically set up the temperature and allows you to save energy and save money. Okay, and where is the AI here? The control logic. Yes.
Like maybe just learns your habits. What do you just put maybe at some time of the day, and then starting from the first week, it just keeps learning.
Yeah, exactly. There is also a table here that summarizes briefly how this algorithm works. Basically, in the first week, it analyzes your habit, your temperature that you have set up manually, and then from the second week, it starts to automatically adjust the temperature. Okay, so this is the AI part. So there is an automatic learning, very sensitive in the first 2 weeks, and then it sort of adjusts the temperature, knowing your habits. So, is it autonomous? Yes, probably after the 2 weeks, yes. And is it a complex task in your opinion? For example, with respect to the Gmail spam filter, is it more complex? Is it simpler? Yeah, the task itself of adjusting the temperature.
More complex.
Is more complex according to your colleague? Do you agree? I would say, I don't know, I don't have a clear answer here. It's probably similar to the Gmail spam filter. I mean, in terms of environment, in one case you have to analyze text. In the other case you have to analyze probably, yeah, I would say it's probably simpler because you have to analyze just one dimension, that is the temperature, and maybe some data from the present sensors that understand if there is someone at home or not. So probably analyzing text is probably more difficult in a way. And as in Gmail spam filter, you just have one dimension, right? So in the Gmail spam filter, an email can or cannot be spam. Here you just have one single data to modify, which is the temperature, okay?
Let's say you have to consider the temperature, the habits, the routine.
Yeah, but yeah, I agree with you. But what are habits in this case? They can be probably summarized with the data from the sensor here, the present sensor that you have on the nest. So they are quite simple habits, right? So, and what can go wrong with this system? Again, if we go back to the previous exercise, what is a classical example of gulf of evaluation here, of a problem about evaluation in this case? Yeah, exactly. A very strange thermostat, temperature on the thermostat, okay? Again, I cannot fully understand how the system works, so when it works, that's perfect. When I see 30 degrees on the thermostat, this can be a very strange temperature, and there can be a sort of gulf of evaluation. And what about the interaction with this tool? How can the user interact with this tool?
Setting the temperature.
Yeah, you can always set the temperature manually, acting on the wheel. So you can also in this case revert the system decision, and you can anyway set the temperature manually. So I think here the degree of user control is probably, let's do the exercise. How would you put the Nest thermostat here in this framework? Yeah, top right probably, okay? So again, it's automatic because the temperature is set automatically, but the user can always set up the temperature manually, okay? So the user can also decide to shut down the AI part of the system and working manually with the thermostat, okay? So I think this is a good example of a tool that has a specific goal, just one dimension, the temperature. The goal is aligned with our main goals in our lives, so saving energy, saving money, and you have a high degree of control. So I think this is a very good example of an AI system that can be used by humans in an effective way. Okay. So another, we will see two examples about conversational assistants, which will be also the goal of the last exercise. Okay, so you will be asked to design and prototype a conversational assistant. So let's start with Alexa.
Say hello to Echo Dot, a compact speaker that's controlled by your voice and Alexa. It's got a new look and a new speaker with improved sound. It's designed to fit almost anywhere, like your bedroom, the kitchen, or your desk, and can play all your favorite music from all your favorite places. Alexa, play music for studying.
Here's a station you might like.
Alexa, start my day. With Alexa routines, it's easy to turn on the lights, turn up the heat, and more with a single command. Alexa can also check your schedule, get you caught up, and keep dinner on track. Alexa, set a pasta timer for 12 minutes.
Pasta timer for 12 minutes, starting now.
Best of all, Echo Dot and Alexa are always getting smarter and adding new features and skills. Echo Dot from Amazon.
Augmenting in this case, according to your colleague, do you agree? Which is the degree of automation of this tool? Also with respect to the other examples. Yeah, it just follows the commands. So probably with respect to the previous example, the degree of automation is, I would say, quite low. It's mainly related to your preferences, right? So probably there are some commands through which you can ask Alexa to play your favorite music, right? So maybe Alexa can learn what are your preferences and automate something in recommending you some music in this case. But yeah, I agree, it mainly follows your command. What about the task itself, the analysis of the environment? Is it more difficult with respect to the other examples? Is it easier? I mean, in the first example, you have text analysis. In the second example, you have an analysis of some data from the sensors of the Google Nest. Here you have some voice recognition task, right? This is the main task. Is it more difficult? Is it simpler, in your opinion? Depends, probably. It also depends on the environment. If it's a noise environment, it is probably a difficult task, right? What can go wrong here? There are some problems that are specifically related to conversational agents. So problems that you will also take into account, hopefully, in the last exercise. So what are the difficulties here in interacting with this system and what can go wrong?
Explaining your goal using the words that the system can understand.
Yeah, exactly. To explain your goal, it may be difficult and you have to use the language of the system, right? And more importantly, you need to know the language of the system, right? And we will see some examples, some funny videos. So again, it may be difficult to explain your goal using the language of the system. Other problems that you can think about? Yes?
I think voice is more difficult than text because it's changed from person to person.
Yeah, exactly. And we will see exactly. We will see an example. You have different things to consider. For example, the accent of the people, the language of the people. So everyone speaks differently, and so analyzing different voices may be difficult. Okay. Same exercise of before. Where would you put Alexa here?
The top left.
top left, yes. Other ideas? Top middle, so here, right? Yes, you have, would say, middle to low level of automation, I agree. And you have a high degree of control in case of Alexa, because it's always the user that starts the conversation, okay? So if you want to start a conversation with Alexa, you have to say, hey Alexa, or okay Google, hey Siri. So you have to pronounce a wake word, and it's the user that starts, yes, hey Siri, that start the conversation. So yeah, I would put it somewhere here. And relating to the comment of your colleague, let's see some videos. In a way, what is your experience with this kind of system? Do you use them? Yes. For which tasks?
Pasta timers.
Okay, pasta timers, a classical example.
Music.
And for music, yeah. So for very simple tasks. And what is your experience? Is it a good experience? Are you satisfied with these tools or not?
It sometimes starts speaking for no reason.
Okay.
Catches what I'm saying when I'm talking to someone else and answers.
Yeah, exactly. So it can be annoying sometimes. It depends on how the voice recognition works, right? So it can also be annoying. And we have some examples related to what your colleague said.
Alright, ball bags. So today we're going to give a bash these things, they call them smart homes or whatever, smart homes. I'm from Scotland, so I've never had any good luck with these things. Like Connect just basically blew up when I tried to talk to it for the first time. So I'm trying to figure out if these things are going to understand a single word I say, so let's give it a bash. Hello Siri. Siri. Hello Siri. Siri, a ball bag. I'm not even doing my accent anymore. I don't know. You try it. Alright, big one. It's pissing down outside. Going to tell us what the weather's like. Hello, Siri. What about the weather, man? What about the weather? Tell me about the weather. Going to tell me about the weather, you big ball bag. Come on. Weather.
It's currently cloudy and 24 degrees in Sydney.
Good effort, big one. Thanks, Siri. And next up, Alexa. Going to tell us what the weather's like. It's pissing down outside. When's it going to stop?
I don't know that.
I don't know how I can be any clearer than that.
I'm not a god, just me.
At least you listen to me though, man. The other man doesn't even listen to a word I'm saying. Doesn't even turn it
Sorry,
on.
I'm not sure.
Lucky last. Hey Google, what's your weather like?
Right now in Surrey Hills, it's 23 and mostly cloudy.
Hey Siri, going to tell us a joke?
Now playing equals wars joke from Dancers of the Dolls by Kurukashiweji.
I love this song. So, that was pretty hit and miss, but could have been worse, you know what I mean? So, definitely better than it was when back in the day when I first tried Siri and I made the iPhone explode, but... Alright, Bob.
Cuckoo! What is raining today? Water.
Yeah.
Oh my God, it answered. What?
It said yeah.
You say yeah.
Yeah, it's her.
Oh my God. Is a woman?
Yeah.
I'm glad to meet you.
What is this thing?
Hello, Cuckoo.
Hey, you're okay.
That's something from
Google.
the Alphabets.
You have to say hey, Google, or okay.
Hey, Google. Okay, Google.
What's the
There you go.
weather?
Yeah.
What's the weather? Ask.
What the weather? You want to know what is the weather?
Tomorrow.
Tomorrow.
In Flagler Beach tomorrow, there will be showers with a high of 65 and a low of 56.
With this, it's a mystery.
Watch it there.
I'm scared. I'm scared. It's a mystery. Oh my gosh. No.
Ask Google to play an Italian song.
Cuckoo. Hi, cuckoo.
You have to say hey or okay.
Hey, okay.
Google.
Tomorrow in London, it'll be sunny with a high of 41 and a low of 30.
It's the temperature in London.
Mama, ask her to play your favorite song.
Play your favorite song.
Cuckoo. Cuckoo.
Yeah, you're cuckoo, all right.
Cuckoo. Play a song for me. Piemontesina bella.
You have to say.
Addio dei giorni passati. Addio.
So, okay, you don't have to tap it first, but to wake it up, you have to either say, hey, Google, or okay,
Hey, Google. Okay, Google.
Play an Italian song.
And then
Play an Italian song.
So it has to light up after you say that, otherwise it didn't hear you correctly.
Yes.
Io no è un salame perché mia capisci cosa dice. I got it.
You're stupid, because I can understand everything I'm saying to you.
Hello.
Okay, so what can we learn from this video, in your opinion? Yes?
She's expecting that the system interacts as a human.
Yeah, exactly. She's expecting a sort of human here, something that can understand her language. That's true. And there are in particular two interactions that the grandmother is expecting, but that are not implemented in Alexa. I don't know if you...
The way in which she is tapping.
Yeah, she is tapping on the device like to another person, right? And this feature is not available on Google Home, okay? And there is another interaction that is missing on Google Home, and she actually tried this interaction. When she asked for a song.
She sang the song?
Yeah, exactly. She first tried with the title, and then she tried to replicate the song, to suggest the song to Google, okay? These are two examples of interactions that could be actually implemented in Google Home and may actually inform the design of a Google Home for older adults, right? But right now these interactions are missing, okay? So we clearly cannot design a system that is suitable for any kind of users, but we need to, form the right expectations for our users. And this video clearly demonstrates that this kind of tools cannot be used effectively by this kind of users, right? So we need to form the proper expectations to our user, and we need to clearly identify our target population before designing these systems that have some AI.
Cuckoo!
Okay. And the last example is about Jibo. I don't know if you have already heard about it. It's again a different, I would say, conversational assistant. Let's see the video.
Se la camera che hai prenotato è la tua stanza da letto e il tuo soggiorno e la tua sala da pranzo, forse una camera non è abbastanza.
I love to express myself. Check out my moves. Slow down.
Jibo, please introduce yourself.
Sure. Hi, my name is Jibo. I'm the world's first family robot.
Yeah, so I mean, this is actually we've developed several prototypes on the road to where we are right now. And certainly, we've done testing all along the way. You know, we very quickly found, and this is just reinforces a lot of what I found as my work at MIT. People want to treat Jibo like a someone, not a something, and they often, at the end of the interaction, would say, we'd ask them explicitly, what's the difference between Jibo and a tablet computer? And they, you know, they owned and had tablet computers, and they said, well, Jibo fits in like family. Jibo's part of the family. You know, Jibo's warm, Jibo's friendly. Jibo's like knows me and responds to me. So people were really resonating with the fact that it's a social robot.
Slow down and you move too fast. You got to make it long and last. Just getting down the cobblestones.
The initial, we call them skills as opposed to apps because robots have skills. The initial skills of Jibo are really focusing on core needs of busy families. So things around communication and coordination, especially if you're trying to do that with a family member who doesn't live with you. And then in terms of bringing stories and content to life, Jibo is a storyteller, has a storytelling competence. Then you can imagine, you know, in Jibo's library of stories, we'll provide some, but you can imagine that's exactly where a developer community create a lot of great stories, content, games for Jibo. So in terms of, you know, so that's what it comes with as the core skills. You know, it's just imagine the possibilities in terms of what Jibo can do in the future.
Finally, I'm a platform. With the help of developers everywhere, my skills will keep expanding. I'm even working on my sense of humor.
So many possibilities for little Jibo, and we cannot and will not do them all. So we definitely want the developer community to work with us on really fulfilling, I think, this next wave of computing, which I think is really going to be around emotion. I think motion is the next wave, this humanized, high-touch engagement with technology. I think is really the next wave, and that's Jibo's like the first of its kind to bring on that whole new humanized way of relating and experiencing technology. That's Jibo.
What are the differences with respect to Alexa? Okay. What are the differences in your opinion? Yes?
Does specific feature that can seems like useless, but the main aim is to make the thing more human, make the human smile at it, like the...
Yeah, exactly. So Jibo, differently from Alexa, can convey some emotion. It looks like, I would say, not a real person, but anyway, it tries to mimic another human. It can convey emotion, and there is this sort of empathic communication. Okay, so Jibo can smile. First of all, it has a screen. It also has some lights here, through which it can convey some information. It can move differently from Alexa. And more importantly, it also has some cameras here which can recognize the user. And actually Jibo, we will see another video, can start automatically a conversation without any wake word. Okay? Where would you put Jibo? Here. So Alexa was there, right?
Maybe top right.
Top right, according to your colleague. So it clearly has more automation because again it can start autonomously a conversation, and I think that this also undermines a little bit the degree of control of the user, right? Because yeah, you don't have control regarding when Jibo will start a conversation. So I would personally put it probably there. Okay, but let's see another video. So just to understand, did you like Jibo? Would you use it, in your opinion? What is your overall feeling about Jibo?
I'm okay with Alexa.
Okay, your colleague is okay with Alexa.
Probably it's helpful for elder people or loneless people.
Okay, it can be helpful for loneless people or
Also for kids or pets.
also for kids. Okay, so it depends from the user. Yeah, in a way. Let's see this other video. It's probably a bit more scary.
Making a robot a part of our family has been one of the biggest challenges I've faced.
Hello, Joanna. Great to see you.
It's like raising a human infant, except not at all. My name's Joanna Stern, and Jibo's been a member of our family for about a month. And it's been a pretty rough month. It began as a pretty simple gadget review. Jibo had been getting a lot of attention because unlike faceless talking speakers like the Amazon Echo, he looks like an adorable character out of WALL-E. The little guy has a 5-inch touchscreen for a face, 2 cameras for eyes, 6 microphones for ears, and a personality.
Why was the robot angry? Because someone kept pushing his buttons.
I think he's as funny as Jerry Seinfeld. That's my opinion. He can twerk, but he can't walk. Come on, come here. Yeah, so there's a lot he can't do. Hey Jibo, play some music.
Music is something I can't do yet. I can't set reminders just yet. I can't show videos. I can't keep a personal calendar yet.
I was expecting way more for $900.
That thing cost $900?
Sorry, did I not mention that? Jibo can do some things.
Thomas Jefferson is the 3rd president of the United States. The forecast for tomorrow shows sun with a high of 51 and a low of 46. 10 minutes it is.
Honestly, I could win the Powerball tomorrow, and my wife still would not let me adopt Jibo. One day I came home and I found Jibo in the corner with his cord wrapped around his head. The next day, he was hidden in the dryer. Another day, the trash.
So why does your wife hate him so much?
It's his eyes, or cameras. I programmed Jibo to recognize family members by name. It's amazing at first, and then it starts to feel like you're being watched all the time.
Hey Joanna, fancy seeing you here.
Is there something I can help you with? The company says you can always put Jibo to sleep, and that everything Jibo sees is never saved by Jibo, let alone uploaded to the cloud. The company says Jibo's like a child right now, in early stages of development. The thing is, I already have a 5-month-old son, who's probably Jibo's biggest fan. My son has no idea what a Jibo is, and every time I see them interacting, I get this feeling, like this is the world he's gonna grow up in, a world where robots are our coworkers and companions. For now though, no.
Goodbye, Joanna. Break a leg.
Is your idea different from before after this video? What is the main problem here that is highlighted by this person here? Yeah, there is this lack of functionality, but I think it's not important. This functionality could be easily added to this tool. She mentioned a specific thing at the beginning of the video. I don't know if you got the sentence. She said, it's pretending to be a human, but I know it's not. Okay, so this can create a sort of awkward situation. And also the other problem is about probably privacy, right? So Jibo has a lot of sensors, including cameras. So you may wonder where these data actually are stored, and it's probably a concern about privacy, right? And also the fact that Jibo automatically starts the conversation may create some sort of strange situations, right? So to summarize, we have seen, I think, two different kinds of AI systems in these examples. So obviously interacting with a computer is a process that allows you to form a sort of mental model of how the system works. And obviously this mental model is used to interact with other devices as well, right? So in terms of mental models, we can split the examples we have just seen in two different categories that suggest a precise mental model. And the first category is AI-based systems that are actually smart tools, okay? So they are like normal tools, like a light switch, like a thermostat, and the intelligence is typically hidden behind the tool, right? So, okay, Gmail spam filter is completely, you don't have a physical tool like this, but let's focus on the thermostat. It's similar to a normal thermostat, and the AI is hidden behind the tool. And so these smart tools look like standard graphical user interface. They aim to, again, augmenting some tasks, acting sometimes autonomously, but typically the user has always the option to revert the system action or to set, for example, the temperature manually. So users are meant to be in control through the interface. There can be some confusion in terms of autonomy versus control. In some cases, think about the gulf of evaluation problems that we have discussed before. So the designer should really try to minimize this situation. But I think this is a very good example of human-centered AI systems. Okay, so the user is always in control, the focus is more on augmenting some tasks, and yeah, the user can revert the system actions in any moment. Then there is the other category in which we can classify Alexa and Jibo, and the other category suggests a mental model in which the AI is a sort of companion for the user, or a social companion for the user. So Alexa and specifically Jibo have some characteristics of a human being. They can speak, they can understand you to some extent. They can even convey emotions in the case of Jibo, but sometimes this interaction can become a bit awkward, a bit strange. Anyway, this kind of interaction with, for example, conversational assistants is often successful because we as humans typically tend to I'm not able to pronounce this word, to give some meaning to computer things, even if these things do not have any meaning at all, okay? So exploiting this that we can see here in this experiment, designers can try to really design something that looks like human and through which users can communicate as with other persons. So for example, this is called the Heider simile illusion. It was an experiment in 1944. So the researchers asked participants to see this video, and then participants were asked what they saw in the video. Okay, so as you can see, there are some figures here that move on the screen, and almost all participants associated a given meaning to that figures. So some participants saw two people falling in love, other participants saw someone escaping from a room, even if these figures are moving randomly on the screen. Okay, so we tend to give meaning to things even if these things are random. So exploiting these anthropomorphic features, we can increase trust in AI system. Okay, and it has been demonstrated that expressing emotions improves efficacy, for example, in collaborative decision-making tasks and in user interfaces in general. Okay? So this interaction can be successful, for example, in conversational agents, because we have this tendency to think about tools as living subjects. So it's in our nature. Yet this cannot work in the long term, and this cannot work if we exaggerate these design features, as we have seen in Jibo, and I think there is another video, but it's not important. Yes, this is Sophia, a humanized robot that is
Hi,
still
Sophia.
more
How
strange
are you?
than
Hi.
Jibo.
Everything
Okay,
is going
so
extremely
without looking at the
well. Do you like
video,
talking with me? Yes, talking to
we need
people
to
is my primary
keep
function.
attention to the uncanny valley. Do you
Hanson
know what
Robotics
is
develops
the uncanny
extremely
valley?
lifelike robots for
Okay, we
human-robot
will see
interactions.
it in a
We're
minute.
designing these robots to serve in healthcare, therapy, education.
And this is the explanation of the uncanny valley. So, as we have seen, our response to an artificial companion, like a conversational agent, may depend on the level of anthropomorphic features. Okay, so we have this graph in which we have completely machine-like systems and humans, right? And this is our emotional response. So as long as we have some anthropomorphic features, our emotional response increase. That's why probably interacting with Alexa can be successful, at least for some tasks like listening to music or pasta timers. But then, before humans, our emotional response drops. And in a way, Jibo is on the edge of the uncanny valley. And our emotional response drops, especially for those systems that pretend to be humans, but actually they are not, okay? So we know that Alexa is not a human, and Alexa is not pretending probably to be a real human. Jibo is on the edge. Sophia, you can see the video, is a robot that pretends to be a human. And for this kind of system, our emotional response drops. And then increases again, obviously, for fully human. So we really need to keep attention to this phenomena, so we can be attached to this kind of object emotionally. Typically, we are not attached to this kind of robots. So to summarize, before moving to the guidelines, we have seen two different categories: smart tools, artificial companions. This is probably, at least in my opinion, the best example of human AI interaction tools. here you can have a successful interaction as long as you pay attention to the uncanny valley. Okay, so let's move to the design of this system, which will be actually the goal of your last exercise. And before seeing some specific guidelines, let's see briefly what is different in interactive AI systems and what are the errors that can arise in interacting with these systems. You have already seen this slide, probably. Just to highlight that there is a difference between an AI system and a traditional user interface, and the main difference is that a traditional user interface always produces the same output, so same input, same output. AI systems instead are performed under uncertainty, right? So we have these intelligent algorithms that can learn over time, so the response of the system may be different tomorrow with respect to today, okay? And they can also be wrong, right? And this clearly influences the design of these systems. So we need to minimize certain errors, but maybe in other cases our system is learning from errors, so errors can also be important in our system. In any case, we need to create the right expectations to the users. So users must know that the AI may fail. How AI may fail? We can have low-stake errors and high-stake errors. So starting from low-stake errors, nothing critical here, but these are examples on about how AI may fail. So, for example, let's focus on Airbnb. Maybe you are traveling for a funeral, and Airbnb suggests you some fun local activities in that place. It's clearly a mistake, but it's a low-stake error probably. You can easily ignore the recommendation, and the problem here is that Airbnb is not able to fully understand your context. Or maybe you are on a long car trip, you cannot move, and your smartphone or smartwatch suggests you, hey, it's time to do some exercise. I can't, okay? So again, you can easily ignore the recommendation, and we can classify it as a low-stakes error. And of course, this error increases when multiple users can use your system. For example, if you think about Spotify, maybe you have the same account for different family members. So I can use Spotify to listen to some music while working. Then my brother use it to listen to Spotify during a party, and then the next day Spotify starts to recommend me some music that I don't like at all, okay? Because it also takes into account the usage of other users. So again, you can easily ignore these recommendations, but it's still something that fails in the interaction between users and the system. So low stakes errors means AI features that are annoying or interacting. Think about Siri that starts speaking without any reason, or they can result in AI features that are useless. But we can also have high stakes errors. For example, when AI causes active harm, in case of, for example, systems that are used for hiring people. AI may also reveal some private information. AI can also show offensive content. I don't know if you have seen the HAII example in the past lectures about this kind of problem. And of course, if you have problems, if you have errors, especially high stakes errors, this is a problem for you as a designer, as a producer of the system. So users will probably stop using your app. You can have press or legal troubles, and also bad reviews, discouraging other users from using the app. So we should try to minimize, especially high stakes errors. Anyway, again, on the main difference between traditional user interface and AI system, you probably know that there are established guidelines for designing traditional user interfaces. And these guidelines, at least some of them, don't apply fully to AI systems. For example, in terms of consistency or error prevention, okay? So in a traditional user interface, it's really important to be consistent, right? So the same click on the same button will produce, hopefully, the same result. Will redirect you to the same web page, for example. This is not the case of AI system, again, because AI systems are not deterministic. They are inherently inconsistent. And also about error prevention. In traditional user interface, you should really try to prevent user error, right? So you should disable a field in the form if you don't want the user to complete it, for example. As I said before, there are some AI systems that learn from your errors. So there may be some cases in which you really want the user to explore your system, to make some mistakes for improving your algorithm. If you think about, for example, reinforcement learning, right? A classical example, if you perform the same Google search on two different computers, you will probably get some slightly different results. So it's not consistent, it's how it works. So this is another definition of AI system taken from the European community. So an AI system refers to systems that display intelligent behavior by analyzing the environment and taking some actions autonomously. And the fact that AI systems need to recognize and predict something influence, of course, the design of this system. As far as I understand, most of you has some background in machine learning, right? Okay. So, as you may know, recognition and prediction can be seen as two faces of the same coin. Recognizing means classifying existing things, while prediction means sort of classifying something that will happen in the future. But anyway, for classifying things, we have two dimensions. The reference, so something that we know it's true, and the recognition or prediction, right, of the system. So if we consider a binary decision, you have a positive or negative decision with respect to a positive or negative reference, right? And okay, you can have multiple metrics for measuring the performance of a machine learning algorithm, but the simplest ones are probably precision and recall, right? What is precision? What is recall? So that's the formulas, right? So what is precision? In this specific example with a binary decision. So precision gives an indication on what?
On how many things are correctly identified as true positive.
Yeah, exactly. So gives an indication on how much I'm correct when I'm saying that something is positive, okay? So for example, when I'm saying that an email is spam and actually is spam, right? So when I hit the target, that's precision. And how can I have 100% precision? Yeah, exactly. So when I don't have any false positive. Okay. So it's important in applications where you really need to avoid misclassifying negative instances as positive. Okay, so for example, real emails from real contacts as spam. And what about recall? What is the difference with respect to precision?
Is the number of positive outcome on the positive references?
No, it defines the ability of my system to identify correctly and capture all the relevant instances. So a high recall value indicates that the model is good, is quite good at identifying positives, while a low recall value means that I'm missing some positives, right? So it's important in machine learning applications where it is important to identify all the positive instances, even if this means misclassifying something, okay? Do you have any idea of a domain or application in which recall is important? Yeah, probably the medical domain, okay? I really want to maximize the number of, for example, sick people that I can identify with my system, even if this means classifying someone who has no problem as sick, because then I will probably understand that it's a bad prediction. So precision and recall are in a way conflicting metrics. If you increase precision, probably your recall will drop. So typically you have to find a trade-off. But just as an exercise, we will try to understand if it's better to optimize for precision or for recall for the examples that we have seen before. So optimizing for precision means that the worst thing is for example, false alarm or a spam email that is not recognized. Optimizing for recall means the worst thing is missing a positive, missing a spam email, for example. Should we optimize these systems for precision or for recall, in your opinion? What about the Gmail spam filter? Would you optimize it for precision or for recall?
For recall too, because it's more important to annoy the user, signaling that something is spam and it isn't, rather than just let the user trust the system and open an email that I missed like spam.
Okay, so your colleague is saying he would optimize for recall, and in this way we are sure that we are excluding all the spam, right, from the inbox folder. This also means that some important emails may be classified as spam, right? Do you agree with your colleague, or would you optimize for precision instead? There is no wrong or correct answer here, obviously. It depends also on your kind of interaction with Gmail. I mean, every day I check the spam folder, so at least for me, it's not a problem if an important email is classified as spam, because I can manually revert the system action and put back the email in the inbox folder. There are some people that never check the spam folder, so in this case, probably it would be better to optimize for precision. It also depends on the usage of the complete system. And yeah, what about the Nest thermostat? Also in this case, I think it depends. You will probably need to find a trade-off. In this case, I would probably optimize for precision, maybe. I'd like to have the right temperature, even if sometimes I see a very strange temperature, because I always have the opportunity to change it manually. Do you have any examples of, again, domains or systems in which it's really important optimizing for precision? Again, in the medical sector, for which task? Yeah, for image recognition, it depends on what you are trying to classify. Again, we have seen that the medical domain can also be a good example for optimizing for recall, to classify all the sick people, for example, without... but yeah, for some tasks it can be an example. I think a good example can be for example, autonomous cars, right? So for critical systems, you really want your car, in this case, to work properly, probably, right? Okay, let's skip the other examples and let's move to the last part of this lecture. So how can we design interactive AI systems? We clearly cannot and don't want to consider just metrics related to the algorithm and to performances. So numbers are relatively important. We really need to include humans in the loop. So we know that the AI may fail. Let's create the proper expectations. Let's explain why the AI has failed. Let's understand when to automate something and when to augment something. And also, it's also important to decide when to AI and when not to AI. So there are cases in which it's better not to use AI at all. And this slide is from Google, actually. So after identifying the needs of our user, we clearly need, before designing the system, to understand how we can solve these needs. And we can ask ourselves if AI can solve the user need in a unique way or not. So this slide summarizes when AI is probably better and when AI is probably not better. So AI is probably better, for example, when the core experience requires recommending different content to different users. So if you need to implement a recommender system, obviously you need AI. Or when the core experience requires prediction of future events, or when personalization will improve the user experience. So if you need personalization, then some intelligent algorithms will be important. There are some cases instead in which AI is probably not better. So for example, when the cost of errors is very high. So again, AI may fail, so when you really want to reduce, to minimize the number of errors, maybe it's better not to use AI at all. Or when people explicitly tell you they don't want a task to be automated or augmented, right? There are some tasks for which people would like to be really in control. In those cases, it's better not to use AI at all. And this is again from Google, and as we will see in a moment, companies like Google, Apple, all have some sort of guidelines related to human-AI interaction to inform the design of these systems. And before looking at the guidelines, when we decide to use AI, it's also important to analyze the characteristics of the features we will use in the system and how these features will impact the user. Because actually, the user tolerance to an AI feature will depend on the role of the feature itself, okay? So we can have critical or complementary features. In general, the more critical an app feature is, the more people need accurate results, right? So if it's a complementary feature like the recommendatory system of Airbnb in the example of before, people can also tolerate some low-stake examples. If instead the AI feature is critical, is the only thing in the system, you really need to minimize the errors. Otherwise, the tolerance of the user will drop. So for example, Face ID that you use on your iPhones to unlock the smartphone, is it critical or complementary in your opinion? It's probably critical, right? Because it can be annoying if it doesn't work, if it doesn't recognize your face, and if it unlocks the screen for another person, it's a problem. It's a very big problem because then the other person can see what happens in your smartphone and can use your data. So it's probably critical, right? Word suggestions on the smartphone keyboard. So you start typing, and on the top corner of your keyboard there are some suggesting words. Is it critical or complementary? It's probably complementary. I can easily ignore this feature and I can continue typing manually, right? And of course, errors in this case can be tolerated more. Then a feature can be proactive or reactive, okay? So proactive features can prompt new tasks and interaction automatically by providing unexpected, sometimes serendipitous results, while reactive features typically help people while performing a given task. So, of course, for proactive features, people don't ask for the results, and so they may have less tolerance for low quality information. So such features, proactive features, can be potentially annoying with respect to reactive features. So you should use proactive features with care, but in some specific cases they can be helpful. So use proactive feature in small amounts at the right moment, and if they are easy to dismiss. And this is a good example, the auto-completion feature of Gmail again. Okay, so as long as you start typing an email on Gmail, Gmail suggests you the next word, for example. So in this case, Gmail is suggesting the name, probably the name of the address included in the email. And this can be useful, and you can easily ignore the suggestion, the proactive suggestion, by continuing typing. Otherwise, if you click on tab, you can accept the suggestion. Then, of course, an AI feature can be visible or invisible, and this, of course, influence the user tolerance. So it's harder for, as you may know, for an invisible feature to communicate its reliability and potentially to receive feedback. Again, it's better to, first of all, have visible features And if you cannot have visible features, if your system is a black box, it's important to explain maybe why something goes wrong. And finally, you can have dynamic or static features. So dynamic features are those that improve over time. For example, in the case of reinforcement learning, or when your system is learning from your errors. And also face recognition, for example, is improving over time on your iPhone. Static features are static features again. So for example, and they can also, they can optionally improve, but just with a software update. And to conclude, what about feedback? This also applies to proactive features. Do not overuse feedback requests or users will get annoyed. So if you have a black box and you want to improve the quality of your recommendations, for example, you can also ask explicit feedback to your users. Did you like this song? Did you like this recommendation? But use these feedback requests with care, otherwise it can be annoying. So we can now see some concrete guidelines on how to implement and design these systems with a set of guidelines that have been proposed by Microsoft in this case. So how can we apply the principles we have just seen in all this lecture in a structured way? By following, for example, these guidelines for human-AI interaction proposed by Microsoft. It's actually a toolkit. We will see an example. There are guidelines, but there are also other kind of systems that can help you in the design phase. Here you have 18 guidelines divided into 4 different categories. They have been proposed by Microsoft Research, that is quite different from Microsoft. So they don't have to sell anything, so I think we can trust them. And the 4 different categories are related to specific interaction phases. Okay, specific phases related to the interaction between the user and the system. So you can have some guidelines that apply initially, before the interaction starts, during the interaction between the user and the system, when the interaction goes wrong, and over time. Okay? And each guideline has a title, a brief description, and also some practical examples of existing systems that follow this guideline. Okay? So, for example, this is a guideline related to the initial phase, so before the interaction starts. So, in your system, you should make clear how well the system can do what it can do. So, help the user understand how often the AI system may make mistakes. Okay, again, we have seen this principle multiple times in these lessons. And on the back of the card there is this example that is about Apple Music. The recommender system in Apple Music uses language such as we think you will like to communicate uncertainty. So it's not saying this song is for you, we are sure that you will like this song, but it communicates uncertainty. Another example, then you will explore these guidelines in details from the website. In this case, a guidelines during the interaction. During the interaction, your system should mitigate social biases. Ensure that the AI system language and behaviors do not reinforce undesirable and unfair stereotypes and biases. And there is also an example in this case. It's about the Android keyboard, but I think it actually applies also for other keyboards as well. The predictive keyboard for Android suggests both genders when typing a pronoun starting with the letter H. So we are mitigating social biases in a way. Another example, in this case, when the AI goes wrong. And in this case, it's important to support efficient correction. Make it easy to edit, refine, or recover when the AI system is wrong. And the example here is about Bing, but again, this applies also for Google search, I think. When Bing automatically corrects spelling errors in search queries, it provides the option to revert to the query as originally typed with one click. Okay? So Bing here is correcting your typing, but you always have the opportunity to look for your exact keywords clicking here on this link. And finally, this is an example of guidelines that should be applied over time. Convey the consequences of user actions. So immediately update or convey how user actions will impact future behaviors of the AI system. Again, it's about explanation. So the example in practice, upon tapping the like-dislike button for each recommendation in Apple Music, there is a pop-up that informs the user that they will receive more or fewer similar recommendations. So the user in a way can understand how your interaction will influence the behavior of the recommendation algorithm in this case. Again, these were the guidelines by Microsoft, and you will use them in the exercise, but there are also other guidelines from Google, Apple as well. And as I said before, Microsoft is providing you actually a framework. Let's close this. A framework which includes, of course, the guidelines that you can explore here on the website, okay, with the title and the examples. But you also have the playbook, for example, that can guide you in the initial phases of your design, okay? And you can use it also in the last exercise for this course. Actually, you can describe the AI feature you want to design and implement, and the playbook will suggest you some scenarios, some use cases to be taken into account when designing these kind of systems, some possible errors that you should try to minimize, so you can have a full picture related to your feature and how this feature can be used by users. So for example, let's imagine to design a conversational assistant as in the last exercise, so I can select this. Then you can select the primary input modality for your conversational AI system, speech, for example. You can say if your system will have a wake word, like in Alexa, or no, like in Jibo. Let's say yes. And then there are a lot of questions that you can answer. And on the basis of your answers, here the playbook is suggesting you some use cases, some scenarios, some errors. For example, the playbook is saying, as usual, include scenarios where the system demonstrates normal operation. That's okay for all kinds of features. But then your system will take speech as primary input modality. Here are some scenarios to consider including in your user testing protocol. Noisy channels. User input is corrupted by background noise, including by capturing other people who may be speaking in the background. Simulate this error by including and blah, blah, blah. So it's suggesting you how to, let's say, in a way, start designing your system and the error scenarios, use cases that you should consider, okay? That's it. Any questions? If there are no questions, we can have a 15 minutes break and then we will introduce the exercise for today, okay?